Welcome back, my friends. This is the 5th class, and in this class we'll cover if statements and flow controls. What is an if statement? The if statement selects actions to be performed. If allows us to make choices within our code and controls its flow. It's in the family of compound statements, those statements that could be nested within other statements. Note, if you're from another programming language, there is no switch or case statement in Python. We'll see an example later how we might handle that. It takes the form of a test every time, and here's what it looks like. If this is true, then do something. If not, do something else. The if this is true statement is our if test. The do something is our if block. So these come together to make our compound statement. Compound statement includes the header, the colon, and the indented statement. Python detects block boundaries automatically by indentation. By convention, Python uses 4 indents within a block of code. But Python won't care as long as you remain consistent with your indenting. Here's a simple example of an if statement. 1 is Boolean true. So this is always going to evaluate to true, or will always succeed. If 1, print it's true. An if branch the header needs to evaluate to true to be able to execute what's in the body of the if block. So this first one prints out it's true. Now let's look at the second example. 0 is Boolean false. So if 0, print it's true, else print nope. So we know that if 0 will not evaluate to true, so that block won't succeed and get printed out. So we're forced to go down to the else statement, and that's what gets printed out. I mentioned earlier that Python has no case or switch statement, but here we have multi-way branching with an if statement, and we use a dictionary for our choices. So choices XL, L, M, S, and XS with 5 different floats assigned to each. We first print your choice of sizes are XL, L, M, S, and extra small. Then we set a variable input underscore 1 equals input. We're looking for user input. We ask them with our optional clause here, please type one of these 5 sizes and see how much they cost. Remember, with if, it's all about choices. So only one of these branches in any given time will be printed out. So based on their choice, it's either extra large, it's either large, medium, small, or extra small. The user in this case, through their input, dictates how that flow will go. But it's never going to go through all these lines. Once the first branch is satisfied, it would move on to the next piece of code. In this case, we don't have anything below our if-else. If there was code beyond this, this piece of code will continue to run, but that's not what we have here. As soon as the condition is satisfied, it would move on to the next section of code. So if they input XL, it will come back with the value of XL, which is $20. If they input S, it's going to come back with the value of S, which is $5. In this particular case, the user selects L for large, and it comes back with the total cost of $15. Before we go any further, let's make sure that we're all on the same page with a few basic truths. All Python objects are either true or false. Any non-zero number or non-empty object evaluates to true. The number 0, any empty objects, and none, the none type, evaluate to false. Equality tests return either true or false, 1 or 0. Boolean operators stop evaluating as soon as the result is known. The if statement takes action on those statements that return true only. So let's look at the guessing game. The object is to guess the number using just if statements. We hard code our number. The guess is 4. The answer is 4. So I start with a print statement. This sets the rules of engagement. You have 1 try to guess the magic number between 0 and 10. I will give you some help along the way. You can play the game as many times as you want. Typically, we wouldn't do it this way. We would use a for loop or something else, a while loop, but we're restricting ourselves just to focus on the if functionality. So we have a variable guess equals int, integer type. We input now, type a number between 0 and 10 to guess. So here we're asking the user for their initial guess. If guess is greater than 4, you guessed, and it prints out whatever their guess is. And we say, ooh, that number is too high, sorry. If guess is less than 4, we say, darn, that number is too low, sorry, but you can play again. Each time this happens, if they chose, for instance, 5 the first time, the flow would go through that first branch, the first if branch, and the code would end. If they chose 3, it would go through the second branch, and then the code would end, right? It's on or off, 1 or 0. If, for instance, they guessed the number 4, they would go through the else branch, the last branch, and say, you guessed the magic number 4, congrats, player. So that's how this works. Step right up, step right up. Welcome to the AARP game. This game is designed to determine when you will become or when you have become eligible to receive AARP benefits or magazine. The AARP age in the US is 50. So some of us are 50, some of us are older than 50, some of us have not gotten to 50 yet, but we will all get there someday. So what do we do here? How does this work? So follow the dots, the red dot. I get the current year by using the now.year statement based on my variable now being set to the Python's built-in datetime.now method. So I have to import datetime to make use of this. It's a very routine thing that folks will do when they have to use anything related to date or time. Now purple dot. I ask the user for the year they were born, and I convert their answer from a string to an integer using the int method, right? Because by default, the input method will convert whatever the user gives us to a string. Okay, now with yellow, I use age to determine how old the user is. So age equals this year minus the year they were born. Now the brown dot, the first age group is for those who are less than 30. Blue dot, since in these first two groups, these folks are younger than 50, I determine the years left by subtracting their age from the number 50. And you see that I do that for the first group and the second group. Now the green dot, we could have easily combined the first two branches together, but I wanted to show you how to use the AND operator with the if statement as well. Now that light purple dot, since the category here is over age 50, bin ARP, my variable, subtracts 50, the age of eligibility, from their age. Finally, light blue, or this turquoise color, having all other ages covered except those that are actually 50 this year and hence have only become eligible this year, I use the age equals 50 statement here. Now we have our same AARP game, except now we've changed the code to add input validation, and we streamline those two branches for anybody who's under 50. So we start off with the red dot. I import sys because I want to use the sys.exit to exit this program if a user happens to enter letters instead of numbers. Then with the purple dot, I need to declare year born first here before I use it in my validation, otherwise it'll throw an error. So I do that at the purple dot. Then at the yellow dot, here is where I check if it's letters rather than numbers that the user has inputted. If so, I let them know through a print statement, and then I exit the program using the sys.exit. Now the brown dot, I must now convert the year born variable to an integer so that I can go on to use it in all my calculations. By default, the input method converts the input that's given by a user to a string. Now with the blue dots, here I force the user to enter a date later than 1900, but less than this year. So that's a pretty wide range, but I don't want anything before 1900. And of course, it doesn't make any sense to have anything in the future. So I limit them there through that first if branch. Now notice here, I'm using 3 different levels of if statements. So I'm using a nested if statement here at 3 different levels. The first one you see is if year underscore born is alpha. I'm checking to see if it's letters. Then here, the second level of validation, if born greater than 1900 and year born is less than this year. So I'll only let them proceed if both those conditions are met. And then finally, I get to the indentation of that particular if statement with the if, elif, and the second elif, which is what I had in the first version of this code. Okay, so let's see this work. Here is our code. Let's kick it off. F5, please enter the year you were born. Let's test our conditions. Let's take before 1900. Your birth year may not be before 1900 or after the current year. Okay, so let's run it again. Let's put after this year. Your birth year might not be. Okay, great. Let's try letters. Hi. Sorry you entered letters instead of numbers. Let's try within range, 1999. 31 more years to go before you're eligible. And let's try someone who clearly is already a member. 1940, you've been eligible for 28 years. Okay, so all these use cases, we proved to ourselves to a good degree that this does indeed work.